Switch back, walk through another one of those. This time, y equals the opposite of x squared plus 4x plus 2. So, first thing to find is the vertex, the coordinate of the vertex specifically. Remember that formula, the opposite of b over 2a. This time, b is 4, so that'll be negative 4 up top. And a is negative 1. So 2 times negative 1 is negative 2. Negative 4 divided by negative 2 is 2. Okay, so the x-coordinate is 2. Now to find the y-coordinate, I plug that in. Now this time, because that's a positive 2, I can just do that. Plus 4 times 2 plus 2. If you want to be very careful with your calculator, you can always wrap that in parentheses. Let's see here, negative 4, that should be 6. I'm doing this in my head, so I hope it comes out right. So the vertex is at 2, 6. Just like before, 0, 2 will be the y-intercept. And let's see here, I'm going to plug, let's plug 1 in with our calculator. And let's see here, so we got 2 is the center, then 1, then 0. And I guess we'll plug in negative 1 just to see how it goes. So if I plug in 1, that'll be 6, 5. Is that right? Yes. And negative 1, negative 5, negative 3. Okay, so let's graph those points. Um, 2, 6, right? 6, 1, 5, 0, 2. There it is. And again, you would graph these points by hand, and then once you have those, you use symmetry to give you the others, and then you draw in whatever part of the curve, because you wouldn't have a graph this big on your calculator. Or, I mean, on your paper. You'd have probably 10 by 10, so you'd only have so much of the square out there. Alright, one more example. One more, I think. This time my a value is a fraction. We'll see how that comes into play. X equals the x coordinate. Remember, this x is the x coordinate of the vertex. Opposite of b over 2a. B is negative 2, so that'd be positive 2. A is negative 1/3, so 2 times a is negative 2/3, which that comes to be negative 3 if you plug that in. The y-coordinate. Negative 1/3, negative 3 squared minus 2 times negative 3 minus 3 equals 0, 3, 0. Oops, which is interesting because this gives me the point 0, negative 3. As a hint, because of the fraction, let's see here, negative 3 comma 0 is the vertex that I'm going to 0. Then I'm going to plug in 3. Then I'm going to plug in 6. Multiples of 3, just to avoid fractions. Negative 3, 0, 0, negative 3. Alright, let's try to graph that. Negative 3, 0. 0, 1, 2, negative 3. 3, negative 12. 1, 2, 3, 3, 4, 5, 6, 8, 9, 10, 11, 12. Alright. if you're looking up in the upper corner, that negative 0.333 is just the rounding for this. And then, of course, symmetry would have given you these points, and then you could have drawn the curve. Notice as you go back and look at those examples, everywhere where the a value was negative, opened down. This had the negative 1/3, which is smaller than 1. So rather than stretching it downwards, or stretching it vertically, it kind of compresses it vertically. And this is much bigger and fatter than it normally would have been. In fact, I'll show you. Most of the parabolas we've done today, where the a value was 1 and we just had an x squared, look like this teal parabola. And now with that negative 1/3, or rather the 1/3 part of that, you can see how much wider that is than the other one. You don't have to understand how I was able to do that teal one so much faster than the one we had in front of us. We'll talk about that in a future spot. Anyway, so there's that. The only other thing is, notice how, depending which way the parabola goes, the maximum y value, or the minimum y value is always at the vertex. Like these two parabolas we have here. Whoa. Whoops, I shouldn't have done that. This is the maximum y value. So if you've got a question that ever asked you, blah, 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 what is the maximum value of whatever, and your equation is a quadratic, what you would do is just find the vertex using that that opposite of b over 2a. Excuse me. You would find the vertex to find the maximum or minimum, depending on which type of quadratic equation you had, using the opposite of b over 2a thing, and plugging that in to get the y value. And the vertex is that where that maximum or minimum happens. Okay. So I know I kind of talked quick and the video was still long and I crammed in a lot of examples. But the good thing about internet videos is you can pause, go back, rewatch, go back, rewatch as much as you need. And we'll be doing this in class for probably a couple days. A lot of those 10 through 30 problems are graphing ones. Should be a lot of time to practice that. The ones that aren't graphing are finding maximums and minimums. Let's say, find the maximum of y equals blah, 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 blah. And what they're asking for, it's just another way of saying, what is the vertex? So there's that. All right. Thank you very much. See you in class.